Actually, I have a very bad Monday.
Yeah, you might have to sit over.
I sit here and also. Yeah, the miles in the chamber. Hardest thing with this class is it is.
Huh?
Hardest part of this class is choosing where to sit.
Well, I'm glad that's the hardest part of the class.
Yeah. Louis, how many quizzes do you left?
4 including today?
For what?
Quizzes.
That's just the last one.
Are they hard? I don't know.
You would know.
Well, I don't know about the future of them, because I haven't made them yet.
Last day late drop. Last day late drop. My brethren need a late drop. Oh, sure. Monday, right? Late drop party Monday.
Oh, it's not a late drop party.
But it is a late drop party. But it is a party. And it is after late drop, so.
I was actually going to have it next Friday, but I'm going to have to push it back.
Monday? This Monday? I was going to bring leftover ham from Easter, but I guess not. We had some pretty good ham in 610. 610? We're all 484. Yeah, I don't know if there were two. What else there was? I don't know.
I'm a little behind schedule, so I'll have to push the late drop party up a few days.
I feel like you just do that so we don't associate it with late drop. We know. We know. From right outside Delaware. Like,
Okay.
barely same thing. The University of Delaware, like there. We're like touching
All right. Hi. Okay. So because we're a little bit behind, all right, I'm gonna push the exercises to be due Tuesday, all right, and then you have a quiz Friday at 11:10 and 11:11. Okay. So on Wednesday, yeah.
We see behind, you mean in front of the other classes, but behind your schedule?
Yeah. Okay. So last time we were working on finding the Taylor series for f of x equals 1 minus x and -3 about x equals 0. Okay, and so we evaluated the derivatives last time, right? So step 1, find the derivative. Step 2, evaluate. And so now we need to find a pattern. We didn't find a pattern, did we?
We plugged in.
Okay, so we did step 2, evaluate. Okay. All right. So let's figure out a pattern now. All right, so first of all, sometimes we're going to switch step 3 and 4. So in the previous examples we did, we plugged in first and then found a pattern. But sometimes we want to find a pattern first, okay, because it just, sometimes it's easier to find a pattern first. Okay, so switch steps 3 and 4. Because sometimes it's easier to find pattern first. Okay? So we're going to find the pattern first before we plug in. Okay, so basically we want to find how are we going to represent the x derivative at 0 based on this. So we want to find a pattern on these derivatives, okay, not on the terms when we get to the series. Okay, so first of all, let's think about this. This looks like it's going to be a factorial. We have 5 times 4 times 3. However, the 2 times 1 is left off. Okay, so I can write this now as 5 factorial, but I don't have the 2 and the 1, so I'm just going to divide by 2. Right, so 5 factorial divided by 2 is equal to 5 times 4 times 3. And I can see that because I can bring this 2 over to the other side and get 5 times 4 times 3 times 2 times 1. That's equal to 5 factorial. Okay? Similarly, f double prime is 4 factorial over 2. Right? Because 4 factorial divided by 2 is just 4 times 3. F prime of 0 is 3 factorial divided by 2, that's just 3. And f of 0 equals 2 factorial over 2, and that's just 1. Does everyone understand that? Any questions so far? Okay, so how are we going to write the nth derivative? How are we going to express that? Very good. N plus 2 factorial over 2. Okay? And I can see that because, for example, here is n equals 3. We have the third derivative. And so if n equals 3, well, if I have 5 factorial, I'm adding 2 to 3 to get to that 5 factorial, and then I divide by 2. Okay? Or if n equals 2, that's the second derivative. And so if that happens, okay, I add 2 to 2, and I get 4 factorial, and then I divide by 2, and so on. So we see that the pattern is that we add 2 to whatever derivative it is, which is n. Okay, so I add 2 to that, I take the factorial, and then I just divide by 2. Any questions? Question?
Maybe.
Okay. Is everyone okay so far? Okay, so then step 4, plug in. Okay, and so with the previous examples that we did, if we plugged in first before finding the pattern, we used this formula. Okay, so this is a Taylor series formula. Okay, both of them are given to you on the front page when I first introduced Taylor series. So we always plugged into this formula. However, now if we find the pattern first, then I am generalizing as an n derivative, so I need to use this first formula. So I plug it into this one, not this one. Because now I generalize the n derivative, which is this, and not this. So if I'm going to find the pattern first, I use this formula. If I find the pattern second and I plug in first, then I use this formula. Okay? So if f of x equals a sum from n equals 0 to infinity of the nth derivative of a, okay, in this case a is just 0, that's the center. So I'm just going to plug that in, over n factorial, times x minus a, which is x minus 0, so just x to the n. Okay? And so now I plug in the nth derivative. So I have the sum from 0 to infinity. I plug in the nth derivative, which is this, n plus 2 factorial over 2. Okay, and then I have n factorial x to the n.